consider a simple energy conservation problem where we have a baseball that we throw into the air with a velocity of 16 meters per second. I want to know the height when the velocity is half that. So how are we going to do this problem? There's a general couple of steps you can start any energy conservation problem with, and you don't even have to think about them. It's just that the total energy or energy of the system at the beginning is going to be equal to the energy of the system at the end, provided there are no external or non-conservative forces acting on the system. So this works with gravity, but if we were to throw friction in, then we would have to add in a work term from friction. But that's not the type of problem we have here. We're going to ignore air resistance for this. So energy of the system at the beginning, well, there are three types of energy that it could have for this kind of problem. We could have gravitational potential, we could have spring or elastic potential, and we can have kinetic. Your book might use T, I don't remember. And these are all at the beginning, and at the end we can have those same types, they just don't have to be in the same amounts, although their sums have to be the same, obviously, in the way I'm writing this. So now if we examine this problem, when we start out, let's just say that we threw the ball from the ground, or we can set wherever we threw it from as 0. So no potential energy at the beginning, or no gravitational potential. There are no springs in this problem, so no elastic potential. At the end, we'll be at some height, so we'll certainly still have gravitational potential. Anytime you have a height, you have gravitational potential. Still no springs, and the ball will definitely have a velocity, because we know it's half the original, so there is some kinetic. Well, now we have a much simpler equation. K initial equals G final plus KE final. And if I fill in what the symbols for these types of energy, if I fill in what they are, that'd be 1/2 mv initial squared equals mg final height plus 1/2 m final velocity squared. And we're given our initial and final velocities and just ask the height. So let's solve the equation for that. So final height equals 1/2 mv initial squared minus 1/2 mv final squared over mg. And I notice immediately I'm not going to have to worry about the masses. So this equation is simply final height is 1/2 initial velocity squared minus final velocity squared over little g. And if I plug in those numbers, 1/2 16 meters per second squared minus 8 meters squared over 9.8 meters per second squared. And if I grab a calculator and do this, I get 9.8